Welcome to LC Insider, your weekly insight into the world of printed electronics, flexible interfaces, and smart design, powered by LC Electronic, the world of printed electronics in one place. In IoT device design, every decision is a trade-off between size, function, and speed. Imagine Michał, an experienced engineer working on a new version of a diagnostic wristband. The client wants it light, waterproof, and as clean as possible. No visible complexity, no bulky parts, no cable mess inside the housing. Michał tries to solve it with classic PCBs, wires, and separate plastic panels. But the more he adds, the bigger the problem becomes. More connectors, more assembly steps, more failure points, and less freedom to shape the product the way the user actually needs it. This is where printed electronics changes the logic of the project. Instead of building electronics as a rigid block and then connecting everything around it, you can print functional layers directly on flexible substrates and integrate multiple functions into one structure. In practice, it means you can combine the HMI interface, sensors, graphics, and conductive connections in a single printed layer, thin, light, and ready to be integrated into the device housing. It's not future tech or a lab experiment. Smart engineering teams already use it to build faster, with fewer parts, and with more control over quality and repeatability. Picture a PET film around 125 microns thick, carrying capacitive buttons, a pressure sensor zone, printed icons, and printed signal paths that go to the microcontroller. This layer weighs only a few grams, bends without breaking, and can replace multiple traditional components at once. With sheet-to-sheet printing technology, layers can be aligned with high precision, which makes it possible to build reliable, repeatable structures, even when the design is dense and multifunctional. Start with the HMI. Modern touch buttons, sliders, and control areas can be printed using screen printing or inkjet methods. Because there are no moving parts, the interface can be thinner, more resistant to water and dirt, and easier to seal for outdoor or industrial use. A typical printed capacitive button is built in layers: a conductive electrode layer, often based on silver ink, then a dielectric layer on top, and finally a graphic top film that carries the icons and visual design. For example, a silver electrode can be printed using an ink like Henkel 725A with very low sheet resistance, and the dielectric layer can be built using an insulating ink like Atlantis PL6051 with thickness in the range of tens of microns and heat resistance suitable for many industrial environments. Put together, this kind of multi-layer HMI can stay extremely thin, often only a fraction of a millimeter, while still allowing options like LED backlighting through dedicated diffusion windows. Now add sensors into the same printed structure. Pressure, proximity, temperature, and even humidity sensing can be implemented without adding extra cables or bulky modules. One common example is a printed force sensing resistor, also known as an FSR. It uses carbon-based inks that change resistance when pressure is applied. The structure is simple but clever: a silver electrode layer, a carbon sensing layer, and a spacer layer with an opening that defines the active zone. When pressure is applied, the contact area changes and the resistance shifts, sometimes from very high values down to much lower ones, depending on the force and the geometry. These printed sensors can be made on PET for stability and chemical resistance, or on TPU when you need more softness and flexibility, for example in wearables or textile integration. Even bending behavior can be engineered. A PET film at this thickness can handle tight bends, but the real durability depends on the number of layers and the ink formulation, so flexible ink systems and good layout choices become part of reliability, not just nice details. On top of function, you also need a modern look and long life, and the graphic layer is where printed electronics becomes very practical. Instead of adding labels, stickers, or extra overlays, you can integrate the full visual design into the top film. UV inks can deliver fine details and good weather resistance, and reverse printing protects icons and markings from abrasion. If you need backlighting, diffuser films can help spread LED light evenly, so the interface looks clean and premium. And because the graphics are part of the structure, not an add-on, you reduce parts, reduce assembly time, and reduce quality issues caused by misalignment or peeling labels. Finally, the part many engineers love the most, the conductive paths. Instead of running wires, using connectors, or adding flat cables, you can print the signal routing directly on the same layer. With suitable silver inks, printed paths can be thin, yet highly conductive, with widths designed to match both electrical needs and process limits. Even longer paths can work without significant voltage loss if the geometry is engineered correctly, and the ends can be prepared for different connection methods, soldering, pressure contacts, or ZIF connectors, depending on how the layer will integrate with the main electronics. When you remove wiring and connectors, you don't just make assembly easier, you remove some of the most common failure points in real products. What does this give you as an engineer? It gives you fewer components and fewer cables. It simplifies documentation and BOM structure. It reduces connector-related problems. It enables prefabrication, because the printed functional layer can be produced, tested, and prepared before final assembly even begins. And it gives you design freedom, because electronics can follow the shape of the housing instead of forcing the housing to adapt to a rigid board. This approach works especially well for applications like HMI panels, in home appliances and HVAC, pressure mats and seat sensors, rehabilitation and physiotherapy interfaces, wearable wristbands with printed circuits, and smart labels that react to environmental changes. The real point is that sheet-to-sheet printed electronics lets you design a full functional layer that combines electronics, mechanics, and visuals in one integrated structure. It's a way to build devices that are cleaner, thinner, lighter, and often easier to manufacture at scale, because complexity is reduced at the source. If you're building a product like Michał's wristband, where waterproofing, weight, and assembly repeatability matter, integrating HMI, sensors, and conductive routing into one printed layer can turn a hard project into a predictable one, provided you choose the right materials, the right structure, and the right validation plan. Welcome to LC Insider, your weekly insight into the world of printed electronics, flexible interfaces, and smart design, powered by LC Electronic, the world of printed electronics in one place. Thanks for listening. If you'd like to see how flexible electronics can transform your product, reach out at lcelectronic.com.